NEC Article 800.86 addresses outside plant cable entering buildings. This article stipulates that outside plant cable installed inside a building shall not extend more than 50 feet, which is 15.2 meters, unless it terminates in a listed enclosure or is installed within a metallic conduit. It is crucial to understand what constitutes a metallic conduit according to the National Electrical Code. NEC Article 300.5 D provides definitions for metallic conduit, specifying that it includes rigid metal conduit, intermediate metal conduit, or electrical metallic tubing. Therefore, electrical metallic tubing is indeed an acceptable metallic conduit for outside plant cable inside a building, as long as it adheres to the 50-foot maximum length requirement. When transitioning to a plenum cable via splice, it's important to know that once the outside plant cable is spliced to a plenum cable, the plenum cable can enter the building without requiring additional protection. Plenum cables are specifically designed and manufactured to exhibit low smoke and low flame characteristics. This makes them suitable for use in air handling spaces where fire safety is paramount. Relevant NEC articles to consider include NEC Article 800.86, which covers outside plant cable entering buildings, NEC Article 300.5, D, which defines metallic conduit, and NEC Article 300.22, C, which addresses concealed electrical installations in air handling spaces. Understanding these articles ensures code-compliant and safe electrical installations. Firstly, NEC Article 800.86 specifically regulates the installation of outside plant cables inside buildings. Secondly, NEC Article 300.5 D clarifies what types of conduits are considered metallic according to the code. Thirdly, NEC Article 300.22 C details requirements for electrical installations in air handling spaces, influencing the choice of plenum-rated cables. To summarize, using electrical metallic tubing is acceptable for outside plant cable inside a building within the 50-foot limit. Once spliced to plenum cable, no additional protection is needed for the plenum cable entering the building. Adhering to these NEC guidelines ensures both safety and compliance in electrical installations. It is also very important to make sure you are using the most up-to-date version of the NEC codes when consulting them. These are updated regularly, and using an old book of codes can be dangerous, resulting in unsafe conditions. Always refer to the newest edition of the NEC. Consider the application of NEC Article 800.86. This article serves as a cornerstone in regulating the installation of outside plant cables within building structures. Its primary aim is to mitigate potential hazards associated with the presence of non-fire resistant cables within enclosed environments. By restricting the length of outside plant cables to a maximum of 50 feet, approximately 15.2 meters, unless specific conditions are met, the code seeks to minimize the risk of fire propagation and the spread of toxic fumes in the event of a fire. Understanding the nuances of NEC Article 300.5 D is essential for accurate interpretation of code requirements. This article serves as a definitive guide for identifying acceptable types of metallic conduits for electrical installations. By explicitly defining metallic conduits as encompassing rigid metal conduit, intermediate metal conduit, or electrical metallic tubing, the code provides clarity and consistency in the application of conduit specifications. Electrical metallic tubing, commonly referred to as EMT, emerges as a versatile and cost-effective solution for conduit applications within building structures. Its lightweight construction and ease of installation make it a preferred choice for many electrical contractors. However, it is imperative to ensure that electrical metallic tubing installations comply with all applicable code requirements and industry standards to guarantee optimal performance and safety. NEC Article 300.22 C assumes paramount importance in the context of electrical installations within air handling spaces. These spaces, typically found in plenum areas above suspended ceilings or within raised floors, serve as critical pathways for the circulation of air throughout the building. Due to the potential for rapid fire and smoke propagation within these spaces, stringent regulations govern the types of materials and equipment permitted for use. Plenum-rated cables, specifically engineered to exhibit low smoke and low flame characteristics, are mandated for electrical installations within air handling spaces. These cables undergo rigorous testing and certification processes to ensure compliance with industry standards and code requirements. Their use minimizes the risk of toxic fume release and fire spread in the event of a fire, thereby enhancing the safety of building occupants and protecting property. When designing electrical installations that involve outside plant cables entering buildings, it is crucial to adopt a comprehensive approach that integrates code compliance with practical considerations. Firstly, conduct a thorough assessment of the building's layout and construction to identify suitable pathways for cable entry and routing. Secondly, carefully evaluate the distance from the cable entry point to the termination point or equipment location to determine whether the 50-foot length restriction applies. Thirdly, select appropriate conduit materials and installation methods based on the specific requirements of the project and applicable code provisions. Fourthly, ensure that all splices and connections are properly executed and meet industry standards for quality and reliability. Fifthly, implement a robust labeling and identification system to facilitate future maintenance and troubleshooting activities. Finally, document all aspects of the installation, including materials used, installation procedures, and code compliance measures to provide a clear audit trail for inspection and verification purposes. Compliance with the National Electrical Code is not merely a matter of regulatory obligation, it is a fundamental aspect of ensuring the safety and reliability of electrical installations. By adhering to the code's provisions, electrical contractors and installers contribute to the protection of building occupants and the preservation of property. Moreover, code-compliant installations demonstrate a commitment to professionalism, quality, and ethical conduct. The National Electrical Code serves as a dynamic and evolving document that is regularly updated to reflect advancements in technology and best practices in the electrical industry. Stay abreast of the latest code revisions and interpretations to ensure that your installations remain compliant and aligned with industry standards. Engage in continuing education and professional development activities to enhance your knowledge and skills in electrical safety and code compliance. The application of NEC Article 800.86 is crucial when dealing with outside plant cables entering buildings, particularly regarding the length restriction. The 50-foot limit is in place to mitigate fire hazards associated with these cables, which typically have different fire resistance properties than those intended for indoor use. If the cable run exceeds 50 feet inside the building, it must be enclosed in a metallic conduit or terminated in a listed enclosure to provide adequate fire protection. Understanding the definitions outlined in NEC Article 300.5. D is essential for selecting the appropriate type of metallic conduit. While rigid metal conduit and intermediate metal conduit offer robust protection, electrical metallic tubing provides a more lightweight and cost-effective option for many applications. However, it is important to ensure that electrical metallic tubing is installed correctly and meets all applicable code requirements. When transitioning from an outside plant cable to a plenum cable, the requirements of NEC Article 300.22 C become relevant. Plenum spaces, used for air handling, require cables to be plenum rated, meaning they have been tested and certified to have low smoke and flame characteristics. Once the outside plant cable is spliced to a plenum cable, the plenum cable can be run within the plenum space without additional protection, as it is designed to minimize the spread of fire and toxic fumes. When designing electrical installations, consider the specific requirements of the building and the intended use of the space. Factors such as fire resistance, mechanical protection, and environmental conditions can influence the selection of cable types and installation methods. Consulting with qualified electrical engineers and inspectors can help ensure that installations meet all applicable code requirements and industry standards. Proper documentation of electrical installations is essential for future maintenance, troubleshooting, and inspections. Maintain accurate records of cable types, conduit materials, and installation methods, including any deviations from standard practices. This documentation can help facilitate future work and ensure that installations remain safe and compliant over time. In summary, Adherence to NEC guidelines is paramount when working with outside plant cables, metallic conduits, and plenum spaces. By understanding the relevant code articles and applying them correctly, electrical contractors can ensure the safety and reliability of electrical installations while minimizing the risk of fire and other hazards. Always prioritize safety and compliance in all electrical work. The requirements of NEC Article 800.86 are very important to ensure safe installations of OSP cables. The transition from OSP cable to plenum-rated cable is common, and it is essential to understand the splicing procedure and where additional protection is needed. First, review the cable specifications to make sure they are compatible. Second, use appropriate splicing techniques to maintain the integrity of the connection. Third, document the splice location and cable information for future reference. These steps will contribute to a safe and reliable electrical system. Ensuring that all electrical work complies with the NEC is crucial for protecting building occupants and preventing property damage. Adherence to these guidelines is a fundamental responsibility for all electrical contractors and installers. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations. It's designed to ensure safety and proper functioning of electrical systems. The NEC is updated regularly to reflect new technologies and best practices. Always refer to the latest edition to stay up to date. The NEC addresses various aspects of electrical work, including wiring methods, overcurrent protection, grounding, and equipment installation. It covers both residential and commercial installations. Following the NEC is essential to avoid electrical hazards such as fires, shocks, and equipment damage. Failure to comply with the NEC can result in fines, legal liabilities, and most importantly, safety risks. The NEC is not a law itself, but it is often adopted by state and local jurisdictions as part of their building codes. This means that compliance with the NEC is legally required in many areas. To ensure compliance, electrical contractors and installers must be knowledgeable about the NEC and its requirements. They should also participate in continuing education and training to stay current with the latest changes. Electrical inspections are typically conducted to verify compliance with the NEC. These inspections are performed by qualified inspectors who examine electrical installations to ensure they meet code requirements. If an installation fails inspection, corrections must be made to bring it into compliance. The NEC provides detailed specifications for wiring methods, including the types of cables and conductors that can be used in different applications. It also specifies the ampacity of conductors, which is the maximum current they can carry safely. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting electrical circuits from overload and short circuits. The NEC specifies the required overcurrent protection for different types of circuits. Grounding is another critical aspect of electrical safety. The NEC requires grounding systems to be installed to provide a path for fault current to flow back to the source, tripping the overcurrent protection device and energizing the circuits. Equipment installation is also covered by the NEC. This includes requirements for the proper installation of electrical equipment such as panels, transformers, and motors. The NEC also addresses specific requirements for hazardous locations, such as areas where flammable materials are present. These locations require special equipment and wiring methods to prevent explosions and fires. The NEC is a complex and comprehensive document, but it is essential for ensuring the safety and proper functioning of electrical installations. Electrical contractors and installers must be familiar with the NEC and its requirements to avoid hazards and ensure compliance. The NEC provides a framework for safe electrical practices. By adhering to its guidelines, we can minimize the risk of electrical accidents and ensure the reliability of electrical systems. Remember to consult the latest edition of the NEC and seek guidance from qualified professionals when necessary. This will help you stay up to date with the latest changes and ensure compliance with all applicable requirements. It is a collaborative effort to uphold the standards of electrical safety. Always prioritize safety and compliance in all electrical work. Understanding the NEC is not just a professional obligation, It is a commitment to the well-being of our communities.